Hi guys, here we go with continuing 1.3. This is the day 2 note. So we're going to look at some special solutions. Last time we did these normal ones where we ended up with just one solution at the end where x equals 3 or h equals 7 or y equals -3, things like that. What we're going to focus on today though is what happens when we get no solution. What if something else happens? Or what if we get infinitely many solutions? So something completely different also. We're going to take a look at what those look like and how we can identify them. Then we're going to do 2-word problems because one of your homework questions is another one of those word problems. This will be a short video. So, normal examples. This is just what we did in the 1.3 day 1 notes. Here we have 1/2 6h minus 4 equals -5h plus 1. The first thing I need to do is simplify each side of my equal sign. So I'm going to distribute 1/2 through here. 1/2 times 6h is 3h. 1/2 times 4 is -2, which equals -5h plus 1. Now I need to get all my variables on one side, usually the left, and all of my constants on one side, usually the right. So I'm going to add 5h to both sides. If I add 5h to this side, I end up with 8h minus 2. And if I add 5h to this side, it goes away. So I'm left with just a positive 1 or plus 1. Now I'm going to move my -2 to this side, so I'm going to add 2 to both sides because I need to undo -2. This is just like 1.2 now. So I have 8h equals 3. This one we're actually going to end up with a fraction. So I'm going to divide both sides by 8 and get h equals 3 divided by 8. I did this example because I want to talk about how sometimes we just leave these as fractions like this. If I had 2 over 8, then I would simplify it to 1/4, but 3 over 8 I can't simplify anymore, so I can leave it like that, or I can do it as a decimal too. Both options are fine. Now I want to take a look at, or I want you guys to try this example right here. But actually, I'm going to do the normal example. Now I'm going to do a no solution. Then I'm going to do an infinitely many. And then I want you to do one of each kind. So moving to our next one. Again, we do our distributive property first. So I have 15x plus 6 equals 11x plus 4x, which I can combine like terms because they both have x's to get 15x. If the x wasn't on this 4, I couldn't combine like terms, but since they both have an x, I can combine like terms. So I have 15x plus 6 equals 15x. I want all of my variables on one side of my equation and all of my constants on the other side. So I'm going to subtract 15x to the other side. 15x minus 15x is 0 plus 6, which is 6. Then I have 15x and I subtract 15x, which is also 0. So here I end up with 6 equals 0. Let that sink in. Here I have a variable at the end. Here there's no more variable. This is a problem. My variable is completely gone away. Notice also that it's not true. 6 is not equal to 0. This is a lie. Not true. Goodness. That's not true, so I put it in red because it's a lie. Since it is not true and I don't have a variable, we're going to say no solution. This one's not true. There aren't any numbers that I could put into x to make this a true statement. If you can think you can find one, plug it in and make sure. That's why it's so important that we check our solutions, because if I put 3/8 in up here, I'm going to get a true statement. But here I don't. There's nothing I can do to get a true statement. Here's an infinitely many one. Let's take a look how this is a little bit different. This one's kind of like a no solution, but something funny happens at the end. So here I am going to use my distributive property again. So -8y minus 2 equals -8y, and just bringing this down, minus 2. Now I want all my variables on one side and all my constants on the other. So I'm going to add 8y to both sides. Negative 8y plus 8y is 0. Negative 8y plus 8y is 0. So on the left side, I'm left with just negative 2. And on the right side, I'm left with just negative 2 because I added 8y to both sides. This is a true statement. And we can go a little bit farther. If we want to add 2 to both sides, we can get 0 equals 0 if I add 2 to both sides. This is true. I got a true statement here. That means any number that I put in for y. It doesn't matter what the number is. Could be a billion, could be 9, could be negative 15, could be 1.5, could be 0. Any number that I put in for y is going to get me a true statement here. There are infinitely many solutions. Infinitely many solutions. Infinitely many solutions for this one. All right, I want you to try each one here. Go ahead and pause and do those. I'm going to show you the answers in 5, 4, 3, 2, 1. There are our solutions for the your turn. This one should be really easy because we're already done with 1.3 day 1, so you should have done that easily. This one I had 2 equals negative 3. That's not true, so I know there are no solutions to this problem. This one I end up with 2 equals 2 or 0 equals 0. If I end up with something that's true, 2 really is equal to 2, that tells me I have infinitely many solutions. Your homework is going to ask you to identify which ones have no solution, which ones have infinitely many solutions, which ones only have one solution. And the one solution ones you're going to expect to have like x equals 3 for an answer. Here we go into our word problems. Word problems, when we have this type, always talk about things being the same. And when two things are the same, that means that they're equal. So I'm going to always start these with an equal sign. And I'm going to have one thing on one side and then something else on the other side. We're usually talking about two plans or two systems, something like that we're setting equal to each other. So for your cell phone plan, you pay $20 a month plus $5 for each gigabyte of data you use. Your friend's plan is $40 a month, but only $2.5 per gigabyte of data. So your plan on one side of my equal sign, the friend's plan is on the other side. So $20 a month or per month, that's an indicator that this one has my variable on it. Plus $5 for each $20. $20 a month. So we're talking about 1 month. That's just to start the month. Then $5 for each gigabyte. So this is actually going to get my variable on it. Sorry, that one even tripped me up. So plus 5x. Because that's each gigabyte. Then on the other one, we have $40 a month plus 2.5x. Now we're going to compare the two. We want to know what amount of gigabyte, how many gigabytes make these the same. So I want my variables all to be on the left, so I'm going to subtract 2.5 from each side. Then I want all of my constants on the other side, so I'm going to subtract 20 from both sides to get 2.5x equals 20, because 40 minus 20 is 20. Then I'm going to divide both sides by 2.5. We always want to check, right, when we have questions like this. 20 divided by 2.5. It's 8. Okay, good. So I have 8 gigabytes. And that's my solution, right? This is what I didn't know, what I know now. How many gigabytes did your friend have to use for your bills to cost the same? 8 gigabytes. So if you both use 8 gigabytes, it doesn't matter which plan, your plan or their plan. Let's keep moving to the next one. So the county fair charges $10 for admission and $1.25 per ride. The state fair charges $16 for admission, but 50 cents per ride. How many rides would you need to ride for the cost to be the same at both fairs? Again, we have an equal sign because we're going to have one thing on this side and one thing on that side. So this side would be the county fair. And this side would be the state fair. How do I represent the county fair? How do I represent the county fair? $10 for admission, 1.25 per ride. This per is a huge word. State fair, 16 for admission, and 0.5, so 50 cents per ride. I want my variables all to be on the left, so I'm going to subtract 0.5x from both sides. 1.25 minus 0.5 is 0.75x plus 10 equals 16. Then I'm going to subtract 10 from both sides. 0.75x equals 6, because I had 16 and subtracted 10 from it. Now I'm going to divide both sides by 0.75. Using that calculator, so I know I'm going to get the right answer. 6 divided by 0.75 is 8. 8 both times. X equals 8 rides. What this means is that it doesn't matter if you went to the county fair or the state fair if you only ride 8 rides, because it would cost the same amount. 8 rides cost the same at the county fair or state fair. All right, I know this was a shorter video, and it is a shorter homework assignment that is in Clever. Remember, this is page 23, 19 through 24, and number 27. When you're doing this homework, make sure we have out a piece of paper and a pencil. We need to be trying it. If we're trying to do it in Clever and just trying to do it in our head, it's going to be really tough, especially when we have problems like this, where we have that distributed property. It is too much to keep track of. Get out a piece of paper and make sure we do it that right way. Your homework is there in Clever. It's posted. You got this. Make sure you let me know if you have any questions.